So hey guys, in this video we are going to learn the Jacobi's method, which is basically used to find out the eigenvalues as well as the eigenvectors for the symmetric matrix. This you have to understand. The question, so this method is applicable for only symmetric matrix. Okay. So what is the meaning of symmetric matrix? If suppose A is a matrix given, if I take A transpose, both should be equal. So A is equal to A transpose. A transpose meaning that if you interchange the rows and columns, first row becomes first column, second row becomes second column, third row becomes third column, then it will be same. Okay, we'll try and see. So first row I'll make it as column. So 1, root 2, 2. Second row, second column, root 2, 3, root 2. Third row, third column. So 2, root 2, 1. Now both are equal, right? So exactly same. So we can understand that this is basically symmetric matrix. So no need to prove that A is equal to A transpose in the question. For just understanding purpose, I have said that the given question always it will be in symmetric matrix itself in Jacobi's method. Whenever they specify Jacobi's method, you have to understand that it will be given in symmetric matrix. So no need to prove that or show that it is the symmetric matrix. So let us now proceed with the first step of the problem. Now the first step is basically to find out the largest non-diagonal element of A matrix. Okay, this is the first step. Now this non-diagonal is basically off diagonal also. We call it as off diagonal or non-diagonal. Both are same. Now what is the meaning of non-diagonal? Diagonal elements are basically, this is 3 cross 3. Diagonal elements is 1, 3 and 1. This is diagonal elements. Okay, A11, A1, A22, A33. Non-diagonal elements are whatever is left out after eliminating these diagonal elements. If I eliminate these diagonal elements, whatever is left out, this particular thing and this down part, right? So this 6 elements in which one is the largest you have to find out. Root 2 and root 2. 2 is there, 2 is there. So which one is the largest? 2 always will be the largest, but always it will be in the form of what? Aij. This particular form, always remember one more thing, that if it is negative also, negative numbers are also there, you have to always consider the mod of that. Okay, modulus part. That means only positive number you have to consider whenever you are considering what? Largest non-diagonal elements. For example, if it is -2 also, you have to consider as +2. That you have to remember. The largest non-diagonal elements, it is sitting over here 2, and here also 2, the same thing because it is symmetric matrix. So it is in the position A13, first row third column, as well as A31, third row first column. So what is the element? 2. Okay. So Aij, what is I and J values? I value is, when you compare this and this, what I value as what? 1 and J value as 3. Now you'll ask me that why not 3 and 1? You can consider I value as 3 and J value as 1. That is also fine. Anything is fine. Okay, that doesn't matter. Now we'll proceed with the second step. So after finding the largest non-diagonal elements, now we have to find out the theta value. Okay, theta. So one formula is there. That is the step number 2. So what is that formula? Tan 2 theta is equal to 2 into Aij divided by Aii minus Ajj. Okay. Now here 2 Aij, you know, that is the largest non-diagonal element. What about Ai, Ai and Ajj? It is basically the diagonal element, right? These two are the diagonal elements. From where you have to get that? I and J value, if you see, it is 1, 3, 1, 3. Aii will be what? A11 and Ajj will be A33. So the corresponding part from this, we can say that Aii will be 1, 1 and 3, 3. So directly from here you can write, see, if you are getting the non-diagonal elements as 1, 3 or 3, 1, whatever it is. So you understood that you have to take it as A11 and A33, that's it. Because only two numbers are there. If suppose you are getting A 2 1 and a 1 2 non-diagonal elements, largest non-diagonal elements. From this you will get two elements, that is a 2 2 and a 1 1, because only two numbers are there. Simple. So like that, in this case 1 3 3 1 is there, so I will get 1 1 and 3 3. That's it. 1 1 and 3 3. So these two elements I have considered. 1 1 which is equal to 1, a 3 3 which is equal to again 1. So 2 into a eigenvalue is 2 divided by 1 minus 1. How much I get it? 4 by 0. So 4 by 0 we can say it is infinite, because 1 by 0 is not defined. We can say it as not defined or infinite. Now tan 2 theta value is infinite. So what value of tan will give you the infinite thing not defined? It is basically at what? Tan pi by 2, right? So we can, from this we can say tan 2 theta is equal to pi by 2. That implies what will be theta value? 2 will go that side, it will get multiplied with 2 in the denominator, it will become pi by 4. So theta value we got it as pi by 4. This is step number 2, correct? Step number 3. Step number 3, we need to find the orthogonal matrix. Orthogonal matrix always it will be a symmetric matrix also. So I'm going to name that particular orthogonal matrix as S1. Now how to form the orthogonal matrix? That is quite important. Okay. So it is based on these values. Whatever the non-diagonal elements, so 4 elements we have got. That's why I marked in the matrix itself. Here you can see the diagonal elements, 2 elements will be there. Non-diagonal elements, largest value 2 is there. Okay, 2 values. So totally 4. So I'm going to replace those 4 values with cos theta and sin theta. Okay, and other values with the identity matrix. So let us try to understand how we are going to do that. So I'll tell you 2 ways to write the orthogonal matrix S1. Okay, so first method is basically directly you can put it as cos theta minus sin theta and sin theta cos theta. This is 2 cross 2 matrix, sub matrix. This will be in the C. 4 elements we have got. You have to understand here 4 elements we have got here. 1 2 3 4. These 4 elements I am going to remove and put it as this. I am going to replace it with this matrix, cos theta minus sin theta cos theta. Directly you can put it over here. So I'll show you how to do that. This I am going to name it as what? S1. Now I am going to remove this 1 2 2 and 1. I am going to place this submatrix, that will be cos theta minus sin theta and sin theta and cos theta. Then what about rest all elements? The rest all elements will be placed by what? Identity matrix. So what you understand by identity matrix? You might have seen identity matrix is basically 3 cross 3. It will be 1 0 0 0 1 0 0 0 1. This is identity matrix. So in place of the other elements, so whatever the space is left out now, that you are going to place it from the identity matrix. So what is there? 0 is a 0, 1 is a 1, then 0 0 0. Done. So you can observe. So I place this particular thing, this, this and this. Correct? Done. This is how you have to do. While practice, you will directly write. No need to consider. I'm just for this is the first video based on this Jacobi's method. That's why I'm explaining each and every point. Okay. From the next question, directly we'll be doing. Okay. Okay. Fine. So we have got the we are going to find out the orthogonal matrix. In that we have placed the cos theta sin theta. Now one more method I'll tell you how to write. Okay. You can consider second method or anything. So in that method, what you have to do, whenever you are getting the plane, wherever, so we'll consider the plane in the sense based on aij. What is aij? Ij value I got it as what? 1 3 or 3 1, anything, it's the same thing. Okay, so aij we got it as, so we are going to find out the orthogonal matrix in this plane 1 3 aij plane. Whenever 1 3 comes, The elements you are going to write, the diagonal elements, always remember it will be cos theta. What is I values? 1, j values 3. You can consider vice versa also, it's the same thing. Okay, so a33 diagonal element again cos theta, a13 it will be minus sin theta, and a31 it will be sin theta. In this way also you can substitute the values. It's the same thing. See, always remember diagonal elements, always it will be cos theta. Diagonal elements in the sense wherever you are going to place it. It is not like all the diagonal elements is cos theta. Okay, so wherever the parts you are going to place, it will be cos theta. That you have to remember. Then minus sin theta, minus sin theta. This is also a way to remember. Elderly. See, ij, if you are getting 1 2 plane, that means you got the 1 2 as the, or 2 1 as the largest non-diagonal elements. There also same thing. See what will happen. A11 you will consider cos theta, a22 you will consider sin theta, sorry, you will consider cos theta. Then what is left out? Two more elements, a12 and a21, right? So a12 will be minus sin theta and a21 will be sin theta. Okay, so this way you can remember. Now cos pi by 4, cos 45 is 1 by root 2. Then minus sin 45 minus 1 by root 2. Then sin 45 1 by root 2. Cos 45 1 by root. Pi by 4 means 45. Okay, 45 degrees. 180 by 4, which is 45. Now we got S1, which is the orthogonal matrix. Now we are going for the third step, most important. We'll call it as the first transformation matrix or first rotation. So first transformation matrix, I am going to name it as what? B1, which is equal to S1 inverse into A into S1. And always remember, whenever you are going to find out S1, what is S1? S1 is basically the orthogonal matrix. What is the meaning of that? One property you have to understand there. Whenever orthogonal matrix inverse you want to find out, you see S1 is orthogonal. If I want to find out S1 inverse, then it will be always equal to the S transpose, S1 transpose. So S1 inverse is always equal to S1 transpose when it is a orthogonal matrix. So you can directly write it is S1 transpose. No need to put in the calculator and find out the A inverse and all. Okay, into A into S1. So B1 is the first transformation matrix or first rotation. This we are going to find out. Now what we are trying to reduce it to? This B1 should be reduced to a diagonal matrix. What is diagonal matrix? Only the diagonal elements will be there, non-diagonal elements will be 0. Okay, so diagonal elements should be there, that means some values. Other non-diagonal elements will be all zeros. That form you have to bring from the B1 matrix, that means first transformation matrix. Now S1 transpose, see S1 is sitting over here, just you have to take the transpose. A is the matrix which is given, don't get confused here, I am using S1, B1, A is the question matrix, whatever is given in the question, that is A matrix. Okay, so S1 we just found out, that is the orthogonal matrix. You have to multiply with the A matrix, again multiplication of S1. So I'm going to consider the transpose of S1. Okay, so here I have written the S1, this is A. Now you have to consider S1 transpose, this is basically the S1 inverse. Okay, so transpose, just you have to write it over here, change the row into the columns. Okay, just Now after the multiplication of all these three metrics, you will be getting the b1 value as, you can put it in the calculator and find out the answer for b1. So if you see over here, the b1 matrix, the first transformation matrix or first rotation matrix we have got, it is not a diagonal matrix. That you have to understand, because here diagonal elements values are there, that is fine, but a non-diagonal elements all the values should be 0. But here 2 is sitting, 2 is sitting, so this is not a diagonal matrix. Now since this is not a diagonal matrix, so we have to go for the second transformation matrix also. Okay, second iteration also we have to do. Now so what to do? Again same thing we have to follow. Now remember that in the question, we'll go back to the question itself. In the question we have considered the A matrix. Okay, then we went for the orthogonal matrix S1. Then for the orthogonal matrix we went for the first transformation matrix B1. Now the second transformation matrix, it will change everything, right? Now B1 will be treated as the question itself, A matrix. This you have to understand. Whatever we have got the matrix B1 in the first transformation, that will be considered as A. Okay, so no need to write A, I'm just telling. Then we have to proceed the same thing. Again, from the first step we have to follow. Again, we have to start with the first step based on A matrix, but here it will be instead of a B1. That's it. So again, we'll follow the same steps. We have to find the now largest non-diagonal element of, now it is B1. Remember, not A, B1. So in this, what is the largest non-diagonal element? It will be 2, right? Diagonal elements is this one. Non-diagonal elements from this you have to take. So option is between 0 and 2. So I have to consider 2. So it is in which place? It is in I12 and 21, right? So I can write this I12 and I21. Both are same. It is equal to 2. As I said, when you consider 1, 2 and 2, 1, you also write it as, write these, see total how many elements will be there? 4 elements, right? So it will be A11. How much is A11? 3. And A22 along with this only you have to consider. So A22 is 3. Okay. I hope you understood. See here 1, 2, 2, 1. So I will consider 1, 1, 2, 2. Earlier it was 1, 3, 3, 1. So that's why I consider 1, 1, 3, 3. Here it is 1, 1, 2, 2. And 2 theta. So what is tan 2 theta? 2 into Aij divided by Aii minus Ajj. So what is the value? 2 into Aij means this one, that is 2 divided by 3 minus 3. Again the same thing, you are getting it as infinite. So the theta value also remains the same. That means 2 theta is equal to pi by 2. So that implies theta value is equal to pi by 4. So now the next step was to find the orthogonal matrix. There it was S1. We consider here S1, right? S1. Now we'll consider S2. This B1 matrix I am going to replace it, right? So the whatever the 4 elements we have got. So what all 4 elements we have got, which places? You can see over here 1, 2, 2, 1, 1, 2, 1, 1, 2, 2. This 4 places I am going to remove, right? Simple thing. So I am going to substitute what values? I am going to write it as cos theta minus sin theta and cos theta. As I said, diagonal elements, you remember diagonal elements cos theta, then other things minus sin theta and sin theta. This you have to remember. Okay. Next, what about other elements? As I said, identity matrix. So it will be 1 0 0 0 1 0 0 0 1. So only change is that this particular thing will change into 1. That's it, done. Now this is 3 cross 3 matrix. S2 we have got. Now after getting S2, we have to substitute the values of cos theta value. So again the same logic. So cos pi by 2, pi by 4, which is 1 by root 2, minus 1 by root 2, 0, 1 by root 2, 1 by root 2, 0, 0, 0, 1. So S2 matrix also done. Next we'll go for the second transformation matrix. We have to consider here B2, not B1, B2. So B1, B2 is equal to S2 inverse into B1 into S2. S2 inverse, as we know, orthogonal matrix. So since we can directly write this equal to S2 transpose B1 and S2. Don't write here A and L. Okay. So we have to consider the first transformation matrix, that is here B1. So now you have to substitute the values. S2 transpose, so S2 is sitting over here. This particular thing, you have to take the transpose of that, multiply with B1, which we got it from the first transformation matrix, and again S2 you have to multiply. After multiplication, we got the B2 value, which is the second transformation matrix. Now this is a diagonal matrix. You can understand from this that only diagonal elements is there, non-diagonal elements all are 0. So we can directly write them, we can stop the procedure here. We have second transformation matrix, we have stopped. If it is not there, we can go for third transformation matrix also, same procedure you have to follow. Okay. So here it is a diagonal matrix, you can write. So since it is a diagonal matrix, we can write the eigenvalues directly from where? Directly from the diagonal elements, from the diagonal elements. So how to write that? The eigenvalues corresponding to eigenvalues of A matrix, which is the question given, is 5, 1 and minus 1. So 3 diagonal elements. 3 cross 3 matrix was given, so 3 eigenvalues will be there. That's what we have written here. What about corresponding eigenvectors? How will you find that? So for that also one simple multiplication is there of the matrices, that also we have to understand. So here we have done 2 iterations, right? One is first transformation and second transformation. But which we are going to multiply? Here students gets confused. So you need to be careful. So the corresponding eigenvectors, how to find? Be careful with the multiplication. The orthogonal matrix which we have found from the first transformation matrix and second transformation matrix, I'll just show you that. So from the first transformation matrix, before that we had one orthogonal matrix which is S1, this particular thing. And before the second transformation method matrix, we also had the S2, which is also an orthogonal matrix. These two matrices we are going to multiply. Now you'll ask me, what if I am getting the answer from the first matrix itself? That means if you're getting a diagonal matrix here itself, then the procedure will be stopped here, right? Then directly from the S1, you have to write the column will represent the eigenvectors. But here we have done 2 iterations. That means we have got S1 as well as S2, 2 orthogonal matrix. We are going to multiply those 2 orthogonal matrix. Remember, students will get confused. They will multiply B1 and B2 itself. No. Here what you have to understand, we have to consider orthogonal matrix. So the S matrix I'll consider S1 into S2. That means both you have to multiply. So after multiplication, what we will be getting? So when you multiply S1 and S2, this is S1 and this is S2. So when you multiply both the orthogonal matrix, we will be getting the answer as. After getting this matrix, the column will represent the each eigenvectors. First column, second column, and third column. Okay. So directly you can write the corresponding eigenvectors will be this eigenvectors is corresponding to the eigenvalues represented over here 5, 1 and minus 1. Okay. So 5, 1 and minus 1 we have got the eigenvectors as well. So this completes the entire procedure. So let me just brief you out what we have done actually here. So always remember whenever you are getting a problem, it will be always in what a symmetric matrix will be given. This you have to understand. So whenever they give you one symmetric matrix, we are going to apply the Jacobi's method. One more method is there, Given's method, that will be discussing in the upcoming classes. Okay. So 3 cross 3 is given. That means you need 3 eigenvalues and 3 eigenvectors corresponding to that. First step is basically to find out the largest non-diagonal element for the A matrix, whatever the question is given. So we found out always you have to consider the positive values. If it is negative is also there, you have to consider the mode of that. Okay. After getting that, 4 elements, always remember 4 elements you have to consider. 4 elements. So Aij, non-diagonal element, we got it as largest as 2, which corresponds to A13 and A31. So 1, 3 is there and 3, 1 is there. So it will be 1, 1 and 3, 3 diagonal elements. Okay. So the 4 elements we got. In these 4 elements, we are going to replace it with the cos theta and sin theta. Okay. So before that, we have to find out theta value. So theta value, this formula you have to remember, Aij by Ai1, so Ii minus Ajj. From this you got theta value. After that, third step is to find out the orthogonal matrix, that is basically denoted with S1. So you have to always form in this matrix form, cos theta minus sin theta and cos theta. So you have to fill up this space. So I'm going to remove that 4 elements. I'm going to fill up with this space. Rest all elements will be filled with the identity matrix. So 1 0 0 0 1 0 0 0 1. That identity matrix you have to fill. After that, the first step is to find out the first transformation matrix or first rotation. Always remember, no need to find the inverse. This you have to remember. Okay. We have to just take the transpose of that. You will get the inverse as well, because this is the orthogonal matrix. Always remember, S1 is orthogonal matrix. That means A transpose is equal to A inverse. After multiplication, we have got the matrix. If this matrix is not a diagonal element, then only you have to proceed. Otherwise, we have to stop the procedure here itself. The diagonal elements will be the eigenvalues and the eigenvectors will be S1. We have to see S1, the column, this thing. But here the problem was that it was not a diagonal matrix. That's why we proceeded with again the second transformation matrix. Again the same procedure. Largest non-diagonal element, then tan theta value, then orthogonal matrix S2 we found out, then second transformation matrix, same thing, B2 we found out. Now it is a diagonal matrix, that's why we have stopped the procedure. The diagonal elements will be the eigenvalues. Eigenvectors, in order to find out, remember you have to multiply S1 and S2, which are orthogonal matrix. Okay, when you multiply, the column will represent the each eigenvectors.